The example 1, design the non-overflow section of the gravity dam with the following data. The case 1, the reservoir is full. No tailwater uprips consider. Drain working. Horizontal earthquake acceleration upstream. So we can say that this is okay, and for the vertical earthquake downward. Okay. So this case is similar from the previous lecture, the same condition, and this for the dimension of the dam, gravity dam. And the other thing is for the shear strength, it should be 100 to 210 ton per square meter. Okay. In this case, given the seismic coefficient for horizontal seismic coefficient is for the upstream, and this for the downward vertical. Okay. And from this, we finished to find the vertical force and horizontal force from the previous example. In this case, for the direction of the force, this one is we assume that downward is the positive, and for this one, assume that right hand side is positive. Next, we're going to find the moment of point A, around point A at the hill. In the case of moment, we assume that the clockwise is a negative. Okay. First, before we find the lever arm, to find the moment, we have to find the lever arm from the PV diagram first. For example, we move back to the previous lecture. Okay, so we can check from this 5 dimension from the lever arm. Example, this length is equal to 18.3, or from 55.9 divided by 3. Okay, and from this length is equal to, you should use the different color. Okay, maybe in the black one. Okay, is 61 divided by 3. And this length is equal to 61 2 over 3 of the 61, so it should be 4.6 from the, because we have to compare to this point A to take a moment around point A, and from this point should be 58.76. Location of PEH. And in this case, if we write force is U1, U2, and U3. So this stands for U1 is 7 divided by 3, and for U2 is 7 divided by 2. But for U3 is equal to total length 54.9, subtract 7 divided by 3 and plus 7 again. It should be 22.9. Okay, that is the lever arm of each force. Okay, then we can bring our this length to the table again. Move back to the table. Okay, from the first force, W1 is equal to 49, and lever arm is 4.06, so it's come from the 2/3 of the 6.1. In this case is clockwise, so it's negative. Okay, put this clockwise. And for the W2, okay, this force, vertical force, and this length is come from the 54.9 divided by 3. Okay, and for the moment is the clockwise is negative. For the next initial force for vertical earthquake of the weight 1 and 2. Okay, so this one is mean the force is upward. Okay, and this number is come from the summation of 988 998 plus the 7,033,000 and time 0.1. So we got this number. Is the positive because of is the anti-clockwise. And next, for the initial force from the horizontal earthquake of the W1, so is the this length we show in the Fibonacci diagram is still a negative number. And next is the initial force from horizontal earthquake of the W2. So it's about the length is 61.3, 61 divided by 3, and the is a clockwise angle. So the next is hydrostatic force. Okay, the length is 52 divided by 3, and still clockwise. Okay, it's supposed clockwise. And for the initial force of due to the vertical earthquake is for water is based on this equation is 32. The length is 52 divided by 3, and it's positive because it's anti-clockwise. You see that from this one is the PWEB. If you look back from PWEB, okay, so this one is PWEB. The direction of the is anti-clockwise direction, so why we got the positive moment. Okay. Next, hydrostatic force due to the earthquake. Okay, PEH. Based on this equation, we can estimate the force. Okay, and it can estimate the moment. And PH is the clockwise, so we got the negative. Okay, then the last one is the uplift force U1, U2, U3. We can is all the negative force, but it's upward. And this is for the moment arm or lever arm from what we show in the Fibonacci diagram. And for this one is come from is about 23. Okay, but we already approved it. And all the moment is a positive. Okay, because it's the anti-clockwise. The next is summation of the negative moment and positive moment, and for the balance of the two moments is we got this number, and I think this would not be equal. And for this is for the vertical force is positive, and for the positive vertical force and negative vertical force, positive, and positive is positive is 4,000 and negative is 1,000. So this is summation of force. So we got the summation of the moment divided by the vertical. And before that is the eccentricity is is the location of the resultant force is 33.3, and we can bring to work on the check with the safety criteria in the next section.